So it has been 4 p.m. and I think it's time for us to get started. So, Professor Pan, are you ready? Do you think that we should start it?
Yes, yes.
Okay, so first of all, I would like to welcome all of you for participation in this webinar. My name is Yuanmei Hua, and I am an assistant research fellow at Research Center for Environmental Changes. And today, this webinar 2022 Early Career Researchers in Sustainability Science is organized by Future Earth Taipei Early Career Researchers Working Group. And the aim of this webinar is to provide a platform for young scientists to exchange their research results and knowledge. It happens, take place every Friday since May last year. So it's a great honor for us today to have Professor Pan as our speaker. And let me have a brief introduction to Professor Pan. And he is an assistant professor in Department of Bioenvironmental Systems Engineering, National Taiwan University. And prior to this, he was a visiting scientist at the Argonne National Laboratory, Lawrence Battery National Laboratory, and Tsinghua University, Taiwan. And he received his PhD degree in environmental engineering science from Graduate Institute of Environmental Engineering, National Taiwan University, same as me. And something I would like to address is he's the winner of lots of awards that include Sustainable Chemistry and Engineering Lectureship Award 2022 and the world's top 2% scientists in the field of earth and environmental science and in 2021 and the most jealous, the winner of Young Scholar Fellowship, the so-called Einstein from Ministry of Science and Technology, Taiwan. And also he's the author and co-author of lots of published papers. I think his academic achievements is way more than a young scientist. But today, with the great honor that we can have Professor Pan as our short speech speaker. And today his topic is the role of circular agriculture and the negative carbon technologies to carbon neutral. So I would like to give the microphone to Professor Pan. Thank you.
Okay, thank you, Dr. Yuan. So can you see my slides right now?
Yes, it's good.
Okay. And thank you for your kind introduction. And a great honor to be here to share with you our recent progress on the carbon issue, okay? And my department is called the Bioenvironmental System Engineering. And basically, we are working on the environmental issue, especially in agriculture. So as you can imagine that agricultural activity will also produce a lot of environmental impact, including the wastewater or solid waste. So that is also a very important direction, as well as around the world. For example, the circular agriculture and how that can connect to the carbon neutral or the net zero emission scheme, okay, which is a very hot topic recently. So the topic today I'm going to share with you is the role of the circular agriculture and also the negative carbon technology and how that can contribute to the carbon neutral, okay? And I hope you can have some brief idea after my presentation, because this is a very important and also hot issue around the world. And today, I will introduce again myself a little bit. Okay, so I hold a PhD in environmental engineering from National Taiwan University, NTU, and also a bachelor in geography, also from NTU, and also I stay in Argonne lab and also Berkeley lab for a while before I came back to Taiwan in the bioenvironmental system engineering department. Okay, and as I mentioned before, the bioenvironmental system engineering department, we used to call agricultural engineering, and we changed the name of the department to be the bioenvironmental system engineering, or in short, BSE, in 2001. Okay, so that is in the face of the climate change, the sustainable development, and so on. So the agricultural engineering it's kind of transit, right, to more environmental friendly. Okay, so we also changed the name of our department to be the bioenvironmental system engineering. And my lab in BSE department, okay, is working on the green technology. So as you can see here, the green technology, we also have a dream. Okay, we try to focus on the great things. So we define the great, GREAT, as a green research, especially for the environmental and agricultural technology. And the most important thing is we try to utilize the technology to achieve a circular economy, okay, not just in the agriculture, but also in industry, okay, or in city and so on. Okay, so that is the goal and the dream in our lab. And the major direction right now in my lab, okay, the Green Technology Lab or GT Lab, we have 4 research themes. So as you can see in the figures of these slides, we have 4 directions. And the first one in blue colors, which is dealing with the agricultural wastewater. And we try to use different technologies to extract or recover the useful materials or resources from the wastewater. So as you can see here, there are a lot of useful materials. For example, the biochemicals, the humic acid, lactic acid, and so on. And in addition to the biochemicals, we also have a lot of nutrients, okay, especially from agricultural wastewater. So we can also pull the nutrient out from the wastewater, so we can produce clean water, right? Or sometimes we call that as reclaimed water. So that is basically technology-based research, okay, for agricultural wastewater. And as you can see in the thing 2, we're working on the solid side, and especially from the agriculture. So including the manure and even the food waste from the city, okay, we consider that as a biosolid. And we try to use technology such as the anaerobic digestion. And we also trying to improve the anaerobic digestion, okay, with the electrochemical field. So that is something we call the electro AD to produce biogas digestion, which can be used in the theme 1, and also useful materials. Okay, so one of the materials we call the biochar, and even we can convert the biochar into catalyst or soil amendment. So that is also basically technology-based research, especially for solid waste from the agriculture. And on the right-hand side, we also care about the water quality for agriculture. Okay, so as you can imagine that the water for agriculture comes from the watershed, including the river, the reservoir. Okay, so we also have several projects working on the water quality, or in short, sometimes you will feel the healthy watershed. Okay, so we monitoring. We have monitoring system, and also we evaluate the quality of the water from the angle of ecosystem service and so on. Okay, so that is also including the soil pollution, and also the water quality and so on. So that is basically in the theme 3. And the final theme research, okay, is related to the carbon, CO2, okay, especially for CO2. And agriculture is especially different to the industry, right? We use a lot of fertilizer. So that is a kind of a nutrients, right? We have nitrogen, we have phosphorus, potassium, and so on. So these kind of element will also pose environmental impact if the management is not well, right? So in addition to carbon, we also care about the nutrient cycle, especially in the agricultural system. So that including the air pollution, greenhouse gas pollution from the farmland, from the animal industry, and so on. And also we care about the carbon sink, which we will discuss in the presentation today, okay, how they can be improved by different management practice, and even the CO2 mineralization, okay, as a calcium carbonate, for example. So that is also something we recently start in response of the carbon issue and also the nutrient cycle issue. So this is basically the major research direction in my lab. Okay, so basically you can have some brief idea what we are going to do right now and also in the future. And for today's presentation, I still want to focus on the carbon, okay, CO2. And carbon neutral is not a new term, right? It is already lasted for a few days, a few years. And the concept of the carbon neutral is slightly different to the net zero, which is a very hot terminology recently. And basically, the scope of the carbon neutral is showing here. So the practice, if you want to achieve the carbon neutral, the first step, you need to quantify the carbon emission, no matter from a company or from a product, a service. You need to know the quantity of the carbon, okay? And after that, you need to have a plan to reduce the carbon. Okay, so these are something we call the carbon management. Okay, you use technology or you use different management to reduce the direct CO2 emission from an industry or from a product. Okay, so that is basically on the left-hand side. Okay, you try to reduce by technology, by policy, by management. But at the same time, of course, we cannot reduce all the CO2 emission to zero, right? So sometimes we will have still additional CO2 emission. And in the scope of carbon neutral, how we can do for the additional CO2 emission, we purchase the carbon credit, okay, through the economical system. So that is something we can trade, okay, the carbon, okay, on the market. So basically for whole planets, right, the CO2 emission is kind of net, right, zero. But it is not direct reduced for company, but it is reduced by others company or other service through the economic system. Okay, so this is the idea of the carbon neutral. So where can we get the carbon credit? We can from the forestry, right? From the renewable energy, or from the carbon credit if you improve your process efficiency. Okay, so that is something we can trade on the market. And there are also a lot of report, okay, around the world. And also recently, this is one of the example in Denmark. And they point out the pathway to carbon neutral, especially in agriculture. Okay, so as you can see here, the baseline in 2017 and keep going up by 2050, right? We have this much emission CO2. And through different practice, we can reduce, okay, the CO2 emission by this much. And still we have some remaining emission, right? So we can purchase carbon credit from the market to offset the CO2 emission. Okay, so this is a very good example. Okay, if you want to have a plan to achieve the carbon neutral, right? First, you need to identify the CO2 emission first, and then you need to know what practice we can use and what's the contribution, okay, to the CO2 emission. And if we cannot reduce to really zero, then we can purchase carbon credit. Okay, so this is very good example. Okay, I see recently, and this is the detail for the practice I mentioned before. Okay, so basically they also have a different time scale. Okay, for the coming 2 year, 3 year, and the coming 4 to 6 year, and coming 10 years. Okay, so it is a short term, a mid-term, and long-term action plan. Okay, so this is also something we need to consider when we plan the carbon management plan. Okay, so this is also a very important information I would like to share with you. And especially in agriculture, as I mentioned before, we use a lot of nutrient, right? And nutrient will emit a lot of different type of air pollutant, including the ammonia, okay, NH3, and also NOx, and even the nitrous oxide, N2O, which is one of the greenhouse gases. Okay, so one approach to reduce the emission from the farmland, okay, we can use something we call the nitrification inhibitor. Okay, this is also, I think, very advanced and can give a lot of contribution to the whole greenhouse gas emission, okay, especially from the agriculture. So not just for CO2, right? Because agriculture will produce greenhouse gases like nitrous oxide, okay? So we can incorporate this kind of materials, right? Kind of materials or agent, okay, to reduce the nitrous oxide from soil. And in fact, the nitrous oxide is a very powerful greenhouse gas, okay? So for example, in the UK, okay, the nitrogen-based air pollutant is huge, and most of the pollutant is from agriculture. So for example, the ammonia, okay, you can see almost 90% of ammonia is from agriculture, okay, and due to the fertilization, okay, so that is also happening, okay, because the population will increase, right? So in case you can imagine that the food demand will increase, so you will use a lot of fertilizer, right? So the emission to the environment will also increase in the coming future. So you will see this great impact. Okay, so this is also another very important challenge in addition to carbon. Okay, so this is a brief concept, how the nutrient cycle, okay, in the surface, in the interface of soil and also the biosphere. Okay, so this is for your reference. And in NTU, we also have several experiments ongoing. Okay, for example, we plant cabbage, okay, and we measure the emission intensity for different agricultural practice. Okay, for example, the chemical fertilizer, the organic fertilizer, and even the one with the nitrification inhibitors, and how that can contribute to the reduction of the nitrogen-based pollutant. Okay, so this is something we are working right now in NTU. And another terminology you will hear recently, right? Is net zero. So as you can see here, net zero, right? And the concept of the net zero is slightly different to the carbon neutral. So as you can see, the element in net zero, we have two, okay? The green portion and also the blue portion. And the green portion is similar to the carbon neutral, okay? You need to reduce the CO2 emission by technology, okay? So that is belong to the direct reduction of CO2 emission. But you still have additional emission, right? But you don't purchase carbon credit. Instead, you can create something we call the negative carbon. Okay, so that is the blue part, as you can see here. So including the forestry, right? The direct air capture. So you can create a sink for CO2. Okay, so you have additional emission, right? But I create a sink to kind of offset, right? And to achieve the net zero. Okay, so this is the concept through technology. Okay, there is no carbon trading mechanism. Okay, in the net zero scheme. Okay, so basically you utilize the so-called negative carbon technology. Okay, and this figure, I think it's a very good figure. I seen recently in the indicating the negative carbon technology. And as you can see here, there are two different mechanisms. Okay, the light gray is belong to the photosynthesis. Okay, through the biochemical reaction, and the dark gray is belong to the chemical. Okay, just chemical. So you can see the technology category, right? We have this much option, including the afforestation, the carbon storage in soil, biochar, the bioenergy with carbon capture storage, or in short, BECCS, right? And also direct air capture, DACCS. Okay, so there are a lot of options in terms of the technology. Okay, and you can see here, for example, the biochar and BECCS, you can see the implementation option, right? The feedstock, where are the feedstock, right? You can use the crop residues. Okay, you can use something we call biomass, okay, to achieve. So this is something we call the circular economy, right? And how the circular economy can contribute to the carbon reduction and also especially negative carbon. Okay, that is something you can see the relationship. Okay, so a lot of materials over here is coming from agriculture, right? We have a lot of agricultural byproduct. For example, the rice husk, the rice straw, and even the food waste that can be used to produce, for example, the bioenergy with carbon capture storage and even the biochar. Okay, so this is something connect the circular economy with negative carbon. Okay, and I put some example, okay, for several important negative carbon technology. And this one is for the soil carbon sequestration. Okay, so basically the soil is the largest carbon sink on land, right? So a lot of carbon can transfer into the organic matter and stored in soil. Okay, so this is something proposed by the FAO, okay, of the UN, and how the carbon in soil can affect the something we call the ecosystem service. Okay, so what's the relationship between the soil, between the between carbon, and even the ecosystem? Okay, so this is also something ongoing in our lab. And there is also another very good report by FAO, okay, and especially for this report, there are 6 volumes, and especially in the volume 3, okay, it mentioned the sustainable soil management practice, especially for the cropland. Okay, so you can see there are 5 categories, okay, the soil organic cover, the diversification, the tillage, the nutrient management, and so on. Okay, so this report indicate the carbon sink potential for different practice, and I pull some example, okay, for manure, because recently in Taiwan and also around the world we talk about the manure valorization, right? And also most of the manure are back into the agriculture as a fertilizer. Okay, so in this case, you can see here how much additional carbon storage in soil you can get. Okay, so this is a very good database if you want to calculate the contribution of the negative carbon to the whole carbon neutral or even the net zero. Okay, so for example, the AD, right, anaerobic digestion, you will have the digestion, and if you use your digestion in agriculture, what will be the carbon sink change, and also the compost, okay, application. So this is some information for your reference. Okay, so if you are working on the carbon sink, you can go to this report. Okay, a lot of data in this report, which is very useful. And another option is BECCS, right? So the biomass, we can convert the biomass as a biofuel or bioelectricity, right? And through the process, you will have some CO2 emission. So you can capture CO2 by the carbon capture storage technology. Okay, so this is the concept. So CO2 in the atmosphere will absorb by the plant, right? And we capture the CO2 from the process. So for the whole system, the carbon is negative, right? It's continue going to the geological storage, for example, from the atmosphere. Okay, so this is also something we call the negative carbon. So a lot of bioenergy option, right? You can do the combustion, the gasification, and anaerobic digestions, and so on. Okay, so this is something also developed for a long time. And how we can combine this together, right? We also have a lot of different circular economy concept. So agricultural waste, through different technology, you have different product, right, to produce energy. And if you incorporate the carbon capture storage technology, then that becomes the BECCS. So that is one option to achieve the negative carbon. Okay, so the same idea here. This is a very good figure in Europe, and they collect the organic waste from wastewater treatment, from agriculture through a centralized treatment plant, especially the anaerobic digestion. Okay, so you can produce biogas, right, as energy, and you have digestion, and through different separation process, you can separate the nutrient and also organic matter in the digestion, which can be used back into the agriculture and then produce the clean water. Okay, so this is the whole picture. You can achieve negative carbon as well as you can provide additional nutrient and also clean water. Okay, so in the GT lab, okay, in my lab, we also have several separation process ongoing. For example, this is one of the recent progress we're working on, and we're trying to separate the organic matter from the piggery wastewater, okay, from the chemical extraction and absorption, so we can separate organic portion, and that can be used back into the farming, okay. So this is one example for your reference. And for the nutrient, we have electrokinetic separation, okay. So nutrient is a small molecular, right? So we can use the electric field to efficiently collect the nutrient from the wastewater. So this is also something connected to the process I mentioned before, okay. And due to the time strain, okay, so constraint, so I skip all the detail. And the final one, negative carbon technology. And this is something we did before related to the mineralization. And mineralization is the concept you convert the CO2 gas into minerals. For example, the calcium carbonate or magnesium carbonate, which is a highly stable precipitate, or sometimes we call minerals. Okay, so this is a process you mineralize the CO2 into stable precipitation. Okay, so this is also one of the options in CO2 reduction. Okay, for a few decades. Okay, and this is also one of the report we published a few years ago, trying to calculate the contribution of the mineralization technology and how they can affect different country or different region, okay, and what type of feedstock we can use for mineralization. Okay, we did an analysis. Okay, so if you are interested, you can also go through the link and see how that can contribute to the overall CO2 reduction. Okay, so I think this is the last slide that I would like to share to you today. And basically, as I mentioned before, a lot of negative carbon technology option, and most of the technology can be utilized, depends on the feature of a location. Okay, so you need to have a proper feedstock technology and also the product utilization pathway, right? So you can achieve the whole circular carbon system. Okay, so this is some idea I would like to share to you today, and hope you can have some new idea, okay, through my presentation. So thank you so much for your attention, and I also put my email over here. Okay, so if you have any question, you can send me an email. Thank you.
Okay. So thank you, Professor Pan, and I think you provide a very comprehensive overall picture about how the carbon neutral, or we so-called low carbon economy, this kind of terms. But I think you provide different perspectives, like technology and some management strategies to the achievement of low carbon economy. So if any one of you would like to have some comment or question for Professor Pan, you are welcome to raise your hand or put your question in the chat box. And before you say something, start to talk, please report your name and affiliation to the audience and Professor Pan and all of us. So any voice from the audience?
I see someone raise hand.
Oh, there are two people with the raising hand. So I think let's Dorman, right? So
Yes.
Dorman, can you? Yeah. So
Ciao,
yeah,
Taimong
you are
in
welcome
Chinese.
to speak.
Okay. Thank you very much. Thank you, Professor. My name is Darmansa. I am a PhD student from Environmental Department, Chungyuan Christian University. I think your explanation is very good related carbon neutral. And I experienced join the biogas program in Indonesia in 2019. The biogas for the electrical for the citizen in rural area in Bandar Lampung, and I have problem. The problem is the maintenance for the electricity. Can you explain what the minimum capacity if we convert biogas to the electricity for the rural areas? Thank you, Professor.
Thank you. You mean the capacity, right?
Yes, the minimum capacity, so we can minimize the maintenance for the oil and then chemical to cleaning the plant of biogas, I mean.
Yeah, I think it is a very good question, but it is quite complicated. Okay, especially for a centralized biogas plant, for example. Okay, you need to know the source of your biomass, right? And how much amount, and what's the cost for the feedstock. And of course, you have a conversion reactor, right? And that is, it will also spend your money, right? So it will also have some operation and also maintenance cost. And even for the product, including the biogas, right? You need a biogas purification process. So that will be also additional cost. So usually we will plan the area first, right? Before you install the biogas plant. So the area, the size, right, determine the capacity of the biogas plant. And that is highly related to the cost you spend, also the benefit you can gain, okay, from, for example, selling the electricity, okay, and also you will have some byproduct, right, in terms of the liquid and also the solid, and how you can dealing with this kind of byproduct. Okay, if you go through the biofuel, and then you need an additional process again, right? For example, the catalytic process, and that will also cost additional money. And also for the solid side, if you convert into a biochar and or even to other different materials, it will also increase the cost. So it is really depends on I will say the policy is also important, and also the goal of the biogas plant. Okay, it just provide electricity, or it will provide other materials and resources as well. Okay, so that will determine the size of the treatment capacity. And the treatment capacity is also depends on the technology you use. Okay, so for example, the biogas, you have a lot of different options in terms of the technology. You can use gasification. And for example, will you use the food dye bed for the gasification, right? So that is also a different consideration in terms of the technology, right? And that will also determine your treatment capacity. Okay, so this is the element came to my mind. Okay, so far. So also for your reference when you design the biogas plant.
Thank you, Professor.
Thank you.
Okay, so if that answered your questions, I will move it to another hands up. It's from Yushi Sharma. So are you?
Yeah.
Are you?
Yeah,
okay.
okay.
You are welcome to speak.
Thank you, Professor, for such insightful presentation. I am Ayushi from India and PhD student at CYCU, Chungnyan Christian University. So my question is, you mentioned very simple steps like crop rotation or crop diversification for carbon neutral agriculture. But in countries like India, farmers are more fixated on fixed crop farming because of financial benefits. So how these practices can be translated into policy or in practice?
Yeah, very good question. So I would suggest there is a term called ecosystem service, right? And that is basically the whole concept how the ecosystem can provide the service to human health. And the carbon sink, okay, is one of the function provided by the ecosystem service. So if from the angle of the policy making, right, probably you can, through the concept of the ecosystem service, and you can, for example, educate the farmer, right? If you're working like this, then you can get this benefit for ecosystem service. And of course, you need to convert that into the economic value, right? So that will provide additional incentive for farmer to working on the so-called environmentally friendly practice. Okay, so at the same time, you will gain the carbon credit, right? The carbon sink. Okay, so I think a good direction, right? You can improve the ecosystem service. So not just including the carbon, but you can also maintain, for example, the biodiversity, the nutrient retention, right? Water retention and so on. And it can also provide the food, provide fiber. So I would say that will be a win-win situation, okay, from this angle.
One more suggestion that I would like to ask. Do you think nexus between energy and agriculture or food sector can help to address this idea better?
Sorry. Yes, because the nexus issue, right? The
Yeah.
nexus issue is quite complex. Okay, so for agriculture and energy, is can be connected to something I mentioned as BECCS, right? There are some connection. And of course, it will contribute to the CO2 reduction for sure, right? If you reuse the solid waste from agriculture, for example, and convert into the biogas, and you capture CO2, then it is negative. Okay, so definitely can contribute to overall CO2 reduction. And for food, uh, I since I'm not the expert, okay, in the food, but before we talk about the bioenergy, right, we have an option from the food, right? We can use the corn, the bean to produce the bioenergy. But I think that is also a complex question, right? For example, in Taiwan, we have a very small land, right? So if you sacrifice your land to produce energy instead of the food, then that will be a problem, right? But in the United States, I think that the land is quite available. So in that case, if you have additional land, then you can crop the energy, right? And I think that will also contribute to CO2 reduction for the whole country. So really depends on the situation of a country or a region.
Thank you.
Okay, so thank you. The question from the audience. So, is there any other questions? Please raise your hand or put your question in the chat box. So I think it's my opportunity to ask a question. So,
Okay.
So I have a question about the technologies, and Professor Pan just mentioned lots of negative carbon technology, and I would like to ask that what if what will happen as research continues to develop and impact? I mean, what kind of technology that, from your perspective, you think it is provide a great potential or the ability to solve the problem facing nowadays, especially in Taiwan, from the perspective of agriculture research? I would like to know if we need to prioritize this technology, which one do you think would be most effective or most the best candidate for our options?
Yes. For the agricultural, because we have a lot of waste from agriculture every year, and usually we just burn, right, on the farm. But that will also cause a lot of air pollution. So from my angle, if we just consider the technology, right, the feedstock, or we call the waste from agriculture, usually you can divide into two categories. One category is more dry, right, dry base, and the other one is from the animal industry, more wet. The water content is higher. Okay, so the different property of the feedstock will determine the process, right, of the conversion. So the dry base, from my angle, okay, I think the technology was something we so-called the gasification will be the best solution to dealing with the dry base, okay, the biomass. And for the wet base, okay, which contain more water, will go through the anaerobic digestion. But so far, the technology has a lot of space to improve. Okay, so the end product will be different. I will see in the coming few years, not just for the biogas or syngas, okay, from the gasification. So we can also connect that with the currently the petrochemical industry in Taiwan. because we have a very strong capacity, especially in the petrochemical. So once we have the syngas or biogas, which is highly purified, then that can connect to the petrochemical industry process to produce chemicals. Okay, so we can avoid the fossil fuel-based product by using the biomass-based feedstock. And also you can contribute to CO2. So that is the two major technology also in my lab right now. So we have one line working on the gasification and one line trying to improve the anaerobic digestion. Okay.
Thank you for your answer. And I think, like you say, I think Taiwan have strong potential, especially for the waste, for example, food waste. And for example, we can get methane from the recycling process of food waste. And I think that would be provide a great opportunity for the systems in Taiwan. So at the same time, I see some questions appears in the chat box, but it seems a quite a long one.
Let me see.
So it is a Ganser Satchel. Are you with us?
Yes, I'm in here.
Yeah, can you briefly introduce your question?
Yes, my name is Gangsar Satrio from Chungyeon Christian University. My question is, for a company or an industry to move toward zero carbon or net zero, it is require an enormous fund that most of the time it will also increase the price of their product, and at the end of the day, most of those price increase for move toward net zero are given toward the consumers. Or if they fail to achieve tax zero, the government will impose a carbon tax toward the company, but the company will simply increase the price of their products as the result of that carbon tax. What can we do to avoid this kind of practice by company? Thank you very much.
Yes, thank you for your question. It's a really hard question. Okay, it's more like environmental policy or economics. I think Dr. Yuan is the expert on this field, right? And from my angle, right, we have a principle called the polluter pay principle, right? 3P. And of course, you will reflect the cost on the CO2 reduction to the product price, of course. And on the other hand, because if you emit CO2, right, the government will put tax on you. Sometimes we call that as a carbon fee, right, or carbon tax for a product. So I think that is also a different approach, right, especially from the economic tools, trying to accelerate the CO2 reduction. Okay, so I really have no idea how we can avoid that as it's a two policy, right? And I don't have too much experience on that, but I think still we need to work on that. For example, the international movement, right? So every country, they have their own rule to play the CO2, right? This game. And also if, for example, in Taiwan, if we cannot follow up the movement around the world, then the impact will be the industry. Okay, so the competence, right? And also the profit for a company will be like before. Okay.
Thank you very much, Professor.
Thank you.
Thank you. So I see another hand up from Zhang Hanting. So are you with us?
Hello, can you hear my voice?
Yeah,
Yes.
Okay,
please.
thank you. Hello, Professor Pan. I'm Hao Tin Chang. I'm now is a postdoc, and now I'm have the job in the NCKU Department of Geometrics. Although I'm not the expert in this kinds of fields, but I have one question. As you mentioned before, now there are two parameters related to net zero. One is lower emission, and you give the example like the technology, and another one is remove emission. The example like the forest expansion. And from the perspective of governments, I think they want to know how to calculate the ability of carbon neutral and how to evaluate the cost of carbon neutral, maybe in different city or a country or counties. So do you have any idea or any recommendation can share us how to calculate the ability or evaluate the course of this topic? Thank you so much.
Okay, thank you, Dr. Zhang. This is also a very difficult question to answer. And in the case of Taiwan, the CO2 emission, right, we have a major producer, including the transportation and the industries and also the cities. Okay, so if you're looking at the CO2, in fact, the agriculture is not the biggest, or we say the top three, right? But from the nitrogen point of view, the agriculture will be very significant. Okay, so that is one thing. And if you're just looking at the CO2, of course, if you can reduce the CO2 from the transportation, for example, you use the e-car, right, instead of the fossil-based fuel, then you can reduce the whole CO2 emission by 1/3, okay, of the whole country. And for industry, if you can improve the process efficiency, that means you can reduce the energy, right? So it will directly or indirectly to reduce the CO2 from the industry. And also same to city, right? You can, for example, the food waste, if you can convert into the bioenergy, then you can also contribute. So I think the contribution of the CO2 reduction is relatively easier to calculate, right? But as you mentioned, different technology, the cost is quite different and highly depends on the region, right? Different city or different company, they have a different cost on different technology. Okay, so a very hard question. Okay, it's a not easy job to calculate. Okay, so for the government point of view, I think of course, the cost is very important, right? But we still need to identify the top maybe 5 or top 10, right, practice if you want to reduce the CO2 for a city. Okay, and then you prioritize the technology option, and probably you can get the best something we call the available control technology for CO2. Okay, so this is something I hope it can help you on your research work.
Thank you so much.
Thank you.
So thank you. So since like there is a not like a question, but it's a request that in the chat box it says that would the slides be shared after this conference. So I'm not sure if Professor Pan is willing to share, but I suggest that if you need the information or have some comments or questions, you are welcome to write an email to Professor Pan. And I think he would decide if he is willing to share these slides or not. So that's my suggestions. So in previous webinar, we don't actually share slides or the PDF files via this platform. So I think my suggestion is that you may write to Professor Pan, and I think he would be more than happy to help. So I think because of time limit, so I think we are allowed another last one more question. So any question from the audience or anyone?
I see there is one more question.
Oh, I'm missing someone. Okay, can you?
Yeah, the difficulty. Okay, for the quantification, in EPA they have a kind of project, right, to quantify the CO2 for a company, and there are also several certified institute, okay, like SGS or BSI. They can help you to quantify the carbon emission for a company or for a product, okay. And most of the challenge for the carbon quantification is for some product we don't have the methodology, especially from the IPCC, right? So the carbon quantification is mostly based on the IPCC methodology. Okay, but of course it cannot compile all product, right? So, for example, if you're working on some special product, if there is no methodology, then you will spend more time, right, to define your scope of your process, for example. So that is something came to my mind will be the difficulty of the carbon quantification.
Okay, so thank you. And because of time, I think I'm going to close this webinar, and it's the end of the webinar. So thank you again for your participation. And again, if you have any questions to Professor Pan's speech, please write an email to him. So again, I would like to thank you for your participation. So thank you. So I hope to see you again soon online. So goodbye. Bye.
Thank you. Goodbye.
Thank you. Thank you.
Thank you all.
Thank you.